This is the Sishen-Saldhana Railway line, also known as the ore export line. It connects the huge open-cast iron ore mines near Sishen and Katu in the northern Cape of South Africa with the port at Saldanha Bay in the Western Cape, 861 kilometers away. At 3,780 meters long, that is 3.8 kilometers long, these are the longest production trains in the world, and I've been wanting to see and experience these trains for myself since learning about them at varsity more than 30 years ago. In 1989, the line was awarded a Guinness World Record for the longest and heaviest train, when it assembled 660 fully loaded ore wagons into a train of 7.5 kilometers long. Pulled by 9 electric and 7 diesel electric locomotives, 68,640 tons of ore were carried from Sishen to Saldanha in a single train. It's over a minute since the front of the train passed us, but the photograph shows the train still stretching out as far as the eye can see. In fact, when another engine comes into view, that will only mark the end of the first section of the train, and there will still be 2 more sections of the same length to come past. Construction on the line began in 1973, not by the railway company, but by the then iron and steel parastatal known as ISCOR, opening in 1976. From an altitude of 1,295 meters at Sishen, the line crosses the Orange River about 10 kilometers downstream of Groblershoop. For the next 300 kilometers, the line rises and falls before descending towards the Atlantic coast, reaching the coast about 160 kilometers north of Saldanha. From there, the line follows a coastal route, and we are observing it on that coastal route between Lambert's Bay and Elands Bay. As we come to the end of the first section of 114 wagons, you can see there's 1 electric locomotive and 1 diesel electric loco, as it was at the front of the train. The use of mixed electric and diesel electric power is necessitated by the huge voltage drops which can occur as a result of the long distances between some of the substations along the route, and the huge power consumption requirements of the electric locomotives. If electric-only trains were used, the voltage drop caused would reduce the maximum possible traffic frequency. On the other hand, the electric locomotives also have a strong part to play in the braking of the train. With such a large altitude drop between the mines and the coast, a lot of time is spent going downhill. If normal wheel brakes were used excessively, they would quickly burn out. And so the electric locos provide an important braking function by operating in a reverse mode and generating power back into the grid, providing the engine braking function. The line was built as a single-track line, originally with 10 crossing loops to allow trains travelling in the opposite direction to pass, now increased to 19 loops to handle the additional capacity. In practice, it is always the empty northbound trains which stop in the loops, minimizing the need for the fully loaded trains to pull away from a stop position. It originally operated with only diesel-electric motive power, but with ownership transferred to what is now Transnet Freight Rail in 1977, a decision was made to electrify the line. A voltage of 50 kV AC was chosen instead of the usual 25 kV, in order to haul heavier loads and to allow a larger distance between transformers. At the time, it was the longest 50 kV AC electrified railway line in the world. Initial train lengths consisted of 3 electric locomotives hauling 210 ore wagons, each with a payload of 80 tons. Over time, as the capabilities of the locomotives has increased and the advanced control systems were developed, the capacity of each train has also increased significantly, currently more than double the iron ore carrying capacity as those original trains. Upgraded wagons now carry 100 tons, and train lengths have increased to 342 wagons with a total mass of 41,400 tons and a length of 3,780 meters. A new train leaves the mining area of Sishen every 4 to 5 hours, 24 hours a day. This is the third section we're looking at now. With the larger number of wagons and the higher capacity per wagon, it was necessary to split the train into 3 sections, partly due to the fact that the couplers between wagons wouldn't be able to support the full weight of the train. Initially, 3 locomotive sets were used, with a pair of locomotives located at the front of the train and then in between each section. A very impressive technology called radio distributed power was developed in the early 80s to keep all the locomotives completely synchronized. Only the first loco has a driver, and the power and braking of all the others is controlled from the front. Unfortunately, the system wasn't perfect, and after a couple of spectacular derailments, one of which in 2010 resulted in more than 100 of the fully loaded rear wagons derailing, a 4th locomotive set was introduced at the rear of the train, pushing at about 40 to 50% of its normal power capacity, and providing braking from the rear. The 4th and last locomotive set will come into view shortly. The trains are on their way to the harbour at Saldanha Bay, which apparently has a larger port than Durban, Cape Town, Richards Bay and Port Elizabeth's harbours combined. The Saldanha terminal has some equally impressive statistics and must be quite an impressive place to visit. It has the capacity to load 10,000 tons per hour into a vessel. Operating 24/7, the ore quay at Saldana has 2 berths where 2 vessels of 310,000 tons can simultaneously berth at the iron ore jetty. From arrival to departure, including piloting, berthing, loading, draft survey and deberthing, an ore vessel carrying 170,000 tons will be in Saldana Bay for just 24 hours, while a vessel carrying 240,000 tons of ore will be there for just 48 hours. The train has taken 8.5 minutes to pass us, and is slowing down before entering a tunnel with a sharp bend just outside Elands Bay, a few kilometers south from here, and then going on to Saldana, about 100 kilometers further south. As we look back up the line, remember an empty train will be heading north up this line shortly, and within the next 4 to 5 hours another fully loaded train, exactly the same as this one that we've just watched, will come down this track to a waiting ship. More than 60 million tons of iron ore are carried down this line for export every year. What an extraordinary piece of engineering, and I'm really happy I managed to catch it in between other parts of my trip.